In this lesson, we're going to continue working with exponents, and we're going to learn another rule. We're going to learn what to do if we have a rational, in other words, a fractional exponent. And what you'll see is a rational exponent is equivalent to a radical. So let's stick with the easiest one first, where if our exponent is the fraction with 1 over something. So 1 over n means we're going to take the nth root of it. So for example, this is an exponent of 1/3 means we're going to take the third root of 27. So just a reminder of what third root means. You're most familiar with square roots. So the square root of something is you find a number that you can multiply by itself to get what's under the square root sign. Square roots are actually... square roots really mean this, with a little 2 here, just so we don't write a 2 because it's understood the 2 is there. So the 2 tells me that when I take the square root of something, I'm going to multiply the number by itself twice in order to get what's under the square root sign. So a cube root, which is what a 3 would mean in this example, means that I'm going to find some number that I can multiply by itself 3 times to get what's under the root sign, the radical sign. So the cube root of 27 is 3, because 3 times 3 times 3, 3 times, I said it, equals 27. Just to give another example, say I had the fourth root of 16, so 16 to 1/4. I guess I got that in my example here, but I'll do it here anyway. That means take the fourth root of 16, a number that I can multiply by itself 4 times in order to equal 16, and that would be 2. 2 times 2 is 4, times 2 a third time is 8, times 2 a fourth time is 16. So these fraction exponents where they have 1 on the top just means take that root. So this one means take the fourth root of 81. A number that can be multiplied by itself 4 times to equal 81 is 3. Check it out for yourself. You can always do it in your calculator too. Most calculators have root buttons. You can see on this Desmos calculator, this one here that I'm sort of tapping on and off so you can see it highlighting, is the root button. So I haven't used it on here, but I think I probably, if I want to do the fourth root of 81, I probably do the 4 first, then hit this button. No, maybe not. Maybe I hit the button first, then hit the 4, and then put the 81 underneath. There we go. And it tells me that the fourth root of 81 is 3. So your calculator probably has that option somewhere, maybe as a second function. This one means take the fifth root of 243, a number that can be multiplied by itself 5 times to equal 243. Pretty sure that that is also 3, because 3 times 81 would be 243. You can double check that on your calculator. This one means take the fifth root of negative 32. Now at first glance you might go, wait a second, we can't take square roots of negative numbers. And you'd be right, we can't take square roots of negative numbers, but this isn't a square root. Square root would be a 2 on the outside. This is a fifth root. We can take odd roots of negative numbers. It all has to do with, think of it this way. If I had negative 2 squared, that would equal a positive 4. But if I had negative 2 to the 3, that would equal negative 8, because multiplying negative 2 by itself 3 times would equal a negative answer. Negative 2 to the 4 would equal positive 16. Negative 2 to the 5 would equal negative 32. So these odd numbers here do let us get negative answers. And if I work backwards, that means I can take odd roots of negative numbers and still get my, a acceptable answer. And as you can see, this one here, negative 2 to the 5 equals negative 32. That tells me that my answer to part C needs to be negative 2. And again, you can confirm it. If I were to do negative 2 to the exponent 5, I have to do it in brackets, of course, so my calculator knows what I'm doing. But if I do bracket negative 2, exponent 5, I get negative 32. If I do nth root of, so the fifth root of negative 32, my calculator tells me it's negative 2. So it knows how it works. But I can't do even roots of negative numbers, as I pointed out. So if I try to take, say, the fourth root of negative 16, my calculator tells me it's undefined, which for it is its way of saying error. Because there's no number I can multiply by itself 4 times to equal negative 16. So, looks like I might have just got ahead of myself here. No, it's the fourth root, isn't it? So I'm good. So this 1 over part, again, tells me just take the root. So it's going to be the fourth root of... No, I'm not ahead of myself. That's what I just did. By a coincidence, what I just showed, fourth root of negative 16 is undefined. It's an error, right? Undefined error. Because for the reason I just said, no number times itself 4 times is going to equal a negative answer. Okay, now I've got a negative exponent here. I've got a negative fraction exponent, so we're combining things. You have to watch out. So this means 1 over 125 to the positive 1/3. And 125 to the positive 1/3 means a number that can be multiplied by itself 3 times to equal 125. My answer is 1/5. Likewise, this one's a negative, so it's going to be 1 over the 7th root of 128. I guess I sort of skipped over the part where I wrote it with a positive fraction, but hopefully that's not confusing to you. What number can be multiplied by itself 7 times to equal 128? Well, it turns out to be 2. You can put it in your calculator, but the answer is going to be 2. 2 times 2 times 2 times 2 times 2 times 2 times 2 is 128. So it's going to be a half. If the numerator of a rational exponent is not 1, we raise that radical to that exponent. So in these first examples, you notice that the fraction always had a 1 on the top. All these examples had 1 on the top. So what do we do if it's not a 1 on the top is all we're being asked to think about. Well, we still take the root based on the denominator, but we raise our answer to the numerator. We take the root based on the denominator, so third root, but then I'm going to raise my answer to the numerator. So the third root of 27 is 3, but then I'm going to square it. So 27 to the 2/3 is actually 9. So again, some examples. So I'm going to take the fourth root of 81. And then I'm going to raise it to the exponent 3. Fourth root of 81 just happens to be 3. So 3 to the 3 is then going to be 27. I'm going to take the fifth root of negative 32. We've seen we can take odd roots of negative bases. Fifth root of negative 32 is negative 2. And then I'm going to square negative 2. Negative number squared, if it's in brackets, as this one is going to be positive 4. It's all right to have an improper fraction, and it's also all right to have a negative sign. Negative means 1 over third root of 125, all raised to the exponent 4. So 1 over 5. Actually, what I should be doing, not that it's going to make a difference in the end, but to be proper mathematically, I should put the whole thing. No, sorry, take it back. I think I should put the whole thing in brackets, but I think it's okay. Ignore that. All right, so I got 1/5 to the 4, and 5 to the exponent 4 is actually 625, so it's 1 over 625. Now, if you got it as a decimal, you could just put it in your calculator, but if you're asked to show your work, that's not quite so easy, is it? I'd rewrite that decimal as a fraction in lowest terms. I know that 0.75 could be rewritten as 3/4. Notice how this negative sign is not inside brackets here either. This negative sign is not affected by that exponent. So the negative is going to stay out front. I'm going to take the 4th root of 16, and then I'm going to raise that to the exponent 3. So negative sign stays out front. 4th root of 16 is 2. I'm going to raise that to the exponent 3. It equals 8. So in the end, my answer is -8. Likewise, for E part here, I could rewrite this as -243. Notice how that's inside the brackets this time. To the negative, well, it'd be 6/10, but that would reduce to 3/5. So that's 1 over the 5th root of -243 to the exponent 3. 5th root of -243 is -3. Going to raise that to the exponent 3. It becomes -27. And normally I'd put the negative sign out front, but I don't have to. Or actually I normally put negative signs on top, but either way is fine. Example 3, evaluate. So this one is all about order of operations. So if we have actual subtraction like we do here, we know that's going to come after we've dealt with all our exponents. So we'll do it, but just remember to do it in its right place. So I'm going to rewrite these as fractions, some of these exponents. So I'll have 81 to the 3/4 minus 27 to the 2/3. I already had that as a fraction. So I'll take the 4th root of 81 raised to the exponent 3 minus the 3rd root of 27 raised to the exponent 2. 4th root of 81 is 3. 3rd root of 27 is 3. But remember, this isn't multiplication or division, so there's no exponent laws for a subtraction. I just have to work out what it is and then do the subtraction last. 3 cubed is 27. 3 squared is 9. Now at the end I do my subtraction, and I've got 18 as my answer. Again, same idea for this one, just we've got pluses and minuses separating these things. They have to come as our very last order of operations step. So we're going to do all the other simplifying first before we get to those. So let's just do it. I'm going to take the square root of 81. We're going to do 1 over the cube root of 8 minus 7. Anything that exponent 0 is 1, so I can just write that as 1, plus 10. That's odd. 1024 to the point 1 is the same as 1/10. So square root of 81 is 9. Cube root of 8 is 2, so it's 1 over 2 minus 1. This one's going to be the 10th root of 1024. I can start adding these together since there's no reason not to. That's 9.5 minus 1. That gives me 8.5. And then the 10th root of 1024 is actually 2. 2 times itself 10 times is 1024. So my final answer would be 10.5, or I could do 10.5 or whatever. But they're all equivalent. Write as a single power, then evaluate, express answers in rational form. All right, well, this part about writing as a single power indicates to me that I should be looking for common bases, right? Got the base 9. So we can use our same exponent laws that we've always used since we're multiplying these together. I probably should have them in the same form though. So maybe I'd write this as Let's say 9 to the 7/10 times 9 to the negative 2/10. Or maybe it would be easier, maybe people would find it easier to do as decimals. It doesn't matter. Whether you find decimals, switching the 7/10 to a decimal or the 9/10, the 0.2 to a fraction, what I'm going to do in the end is I'm going to add these exponents together. So 7/10 plus negative 2/10. So I end up with 9 to the 5/10 when I add those fractions together. I can reduce this fraction just like I can reduce any fraction. It doesn't matter that it's in the exponent. So 5/10 reduces to a half. Tells me to take the square root in that case of 9, which equals 3. So I'm able to do all that without a calculator because I know my exponent rules well enough, and it worked out, right? For this one, maybe let's leave this one as decimals rather than fractions this time. See how that works. So I've got the base of 100 here and here and here, so I can use my exponent laws on it. I can do 100 to the negative 2 plus 3.5 on the top, and on the bottom it's going to be 100 to the negative 8 times negative 0.5 because of the powers of powers rule. And that means that I'm going to have 100 to the 1.5 on the top. I'm going to have 100 to the positive 4 on the bottom. Negative 8 times negative 0.5 is positive 4. And then I can divide my powers, which means I'm going to subtract the exponents. 1.5 minus 4 gives me 100 to the negative 2.5. At this point, I think I'll change my 2.5 to a fraction, so I'll make it negative 5 over 2. And the negative means 1 over. The 2 means take the square root of 100. And then I'm going to raise my exponent to 5. So 1 over 10 to the exponent 5, which is 1 over 10,000. And again, because I know the exponent laws, I'm able to do all these steps without having to resort to a calculator. But I absolutely have to know the rules properly, of course, and I have to follow order of operations, because if either of those things break down, then naturally you're not going to get the right answer.